What if the universe isn't marching toward cold, empty death, but toward something far more extraordinary? What if every star that burns, every galaxy that forms, every thought that emerges from conscious minds, what if all of it is building toward a final moment of infinite complexity and consciousness at the end of time? Physicists studying the ultimate fate of the cosmos have discovered that the laws of physics might not permit the universe to simply fade into darkness. Instead, reality itself could be converging toward a point of infinite information density, infinite computational power, and perhaps infinite awareness. Tonight, we journey through evidence that challenges everything we thought we knew about cosmic destiny and the meaning of existence itself. Before we begin, please like and subscribe to our channel, and let us know in the comments below where in the world you're watching from. Prepare yourselves. We begin. In 1852, a German physicist named Rudolf Clausius made a calculation that would cast a shadow over all of human hope. Working with the newly discovered laws of thermodynamics, Clausius realized that the universe had a direction, an arrow of time pointing inexorably toward a specific end. He called it entropy, a measure of disorder, of energy's uselessness, of the universe's slow decay toward equilibrium. The second law of thermodynamics states that entropy always increases in closed systems. Hot things cool down. Organized structures fall apart. Energy spreads out and becomes less useful. And the universe itself, Clausius realized, was the ultimate closed system. No energy enters from outside. No order is imported from beyond. Everything that happens, every process that unfolds, increases the total entropy. This led to an inescapable conclusion. The universe must eventually reach maximum entropy, a state of perfect equilibrium where no energy differences remain, where nothing interesting can ever happen again. Stars would burn out, black holes would evaporate, matter would decay to its simplest constituents. Eventually, in the unimaginably distant future, the cosmos would become a thin, cold soup of elementary particles drifting through ever-expanding space, unable to organize into anything complex. Scientists called this the heat death of the universe. It was a future without hope, without possibility, without meaning. Everything humanity had ever built, every thought ever thought, every love ever felt, all of it ultimately meaningless, destined to dissolve into cold equilibrium. The universe's story, it seemed, ended not with a bang, but with infinite, empty whimper. For over a century, this vision of cosmic doom dominated scientific thinking. Physicists calculated timescales, 10 to the power of 100 years until the last stars die, 10 to the power of 106 years until the largest black holes evaporate, 10 to the power of 1,500 years until even protons might decay. The numbers were incomprehensible, but the conclusion was clear. The universe was dying, slowly but inevitably. But in the late 20th century, a few physicists began questioning this narrative. They asked a simple but profound question. Does the universe really permit such meaningless endings? Or do the laws of physics contain hidden dynamics that could generate something entirely different at the end of time? In 1986, a mathematical physicist named Frank Tipler published a paper that would ignite fierce controversy and inspire a new way of thinking about cosmic destiny. Tipler had been studying the physics of closed universes, cosmological models where the universe eventually stops expanding and begins contracting, ultimately collapsing back to a singularity in what's called the Big Crunch. Previous researchers had assumed that collapse meant death, everything crushed out of existence as space-time itself vanishes. But Tipler saw something different in the equations. He realized that as a closed universe contracts, something remarkable happens to the structure of space-time itself. Time doesn't simply end, it transforms. In general relativity, space-time curvature affects how clocks tick. Near massive objects, time slows down, an effect confirmed by countless experiments. In a collapsing universe, Tipler showed, space-time curvature increases without limit as the Big Crunch approaches. This means that from the perspective of observers within the collapsing universe, subjective time, the time experienced by conscious beings and computational processes, could continue increasing even as cosmic time approaches its endpoint. Here's what makes this extraordinary. Tipler calculated that in certain types of collapsing universes, an infinite amount of subjective time could unfold during the finite duration of the collapse. The last few moments before the Big Crunch, measured in cosmic time, could correspond to eternity measured in subjective time. It was as if the universe compressed infinity into a moment. But Tipler went further. He realized that increasing space-time curvature during collapse could provide unlimited energy for computation. As the universe contracts, gravitational potential energy becomes available, energy that could power information processing. Combine infinite subjective time with unlimited computational energy, and you get something profound: the possibility of infinite computation, infinite information processing, infinite complexity emerging at the universe's end. Tipler called this the omega point, borrowed from philosopher Pierre Teilhard de Chardin, who had proposed that evolution was driving toward a final point of maximum consciousness. But Tipler's omega point wasn't mystical speculation. It was derived from general relativity and thermodynamics, calculated from the equations governing space-time itself. At the omega point, Tipler argued, the universe achieves infinite information processing capacity. Every possible computation could be performed. Every possible thought could be thought. Every possible configuration of information could be explored. The cosmos would become, in essence, infinitely conscious, an ultimate mind emerging from the final convergence of all matter and energy. To understand how the omega point could work, we need to explore the physics of collapsing universes more carefully. Not all collapsing universes reach an omega point. Specific conditions must be satisfied. Tipler identified three key requirements that determine whether a universe converges toward infinite complexity or simply ends in meaningless destruction. First, the collapse must be anisotropic, different in different directions. If the universe collapses uniformly from all directions simultaneously, it quickly reaches a state of thermal equilibrium where no computation can occur. But if collapse happens at different rates in different directions, this creates shear, differential motion that prevents equilibrium and enables continued information processing. Think of it like this. In uniform collapse, everything crushes together uniformly, quickly reaching maximum entropy. But in anisotropic collapse, different regions compress at different rates, maintaining gradients, differences, structure. These differences are what allow computation to continue. Information processing requires energy differences, temperature gradients, structured flows. Anisotropic collapse preserves these indefinitely. Second, intelligent life must survive and deliberately guide the collapse. This is where Tipler's theory becomes truly radical. He argued that as the universe contracts and gravitational energy becomes available, sufficiently advanced civilizations could harness this energy to perform computation at increasing rates as the Big Crunch approaches. Moreover, these civilizations would need to actively maintain the anisotropic structure of the collapse. Without intervention, various physical processes would tend to make the collapse more uniform. But by manipulating matter and energy flows, perhaps using impossibly advanced technologies we can barely imagine, future civilizations could keep the collapse anisotropic, preserving the conditions needed for continued computation. Tipler calculated the specific dynamics. As collapse progresses, the rate of information processing must increase proportional to the inverse of proper time remaining until the singularity. If proper time to the Big Crunch is t, then computational rate must scale as 1 over t. As t approaches 0, computational rate approaches infinity. Integrate over all time, and the total number of computations performed becomes infinite. This wasn't hand-waving speculation. Tipler provided detailed mathematical models showing how quantum fields behave in strongly curved spacetime, how information could be encoded in gravitational degrees of freedom, how the Bekenstein bound on information density evolves during collapse. The physics was rigorous, derived from established theories of gravitation and quantum mechanics. But Tipler didn't stop at showing that infinite computation was theoretically possible at the omega point. He made a claim that seemed to cross from physics into theology. If infinite computation occurs at the end of time, then every conscious being who ever lived could be resurrected. The argument goes like this: you are a pattern of information. Your consciousness, memories, personality, subjective experience, all of it corresponds to specific information states in your brain. These states can, in principle, be computed. Given sufficient computational power and information about your structure, a future computer could simulate you with perfect accuracy. Now imagine a computer with literally infinite computational capacity, the omega point. Such a computer could simulate not just one person, but every person who ever lived. It could recreate their experiences, continue their consciousness indefinitely, even improve their lives by removing suffering or death. Every human who ever existed, every alien civilization that might have emerged on distant worlds, every conscious entity throughout cosmic history, all could be brought back to existence in simulations run at the omega point. This is what Tipler called the resurrection of the dead. Not supernatural miracle, but computational reconstruction based on physical law. The omega point would have access to complete information about the universe's entire history. Light cones converge as the Big Crunch approaches, meaning all information eventually becomes available. With complete information and infinite computation, perfect reconstruction becomes possible. Critics immediately attacked this idea. How could the omega point access information about the past? Doesn't quantum mechanics make perfect measurement impossible? Doesn't the second law of thermodynamics mean information gets lost? How could simulated beings be truly conscious rather than philosophical zombies? Tipler responded with detailed arguments. Information isn't truly lost in closed universes, it's preserved in quantum correlations. The collapse itself provides a mechanism for accessing this information as all light cones eventually intersect. As for consciousness and simulations, he argued that if functionalism is correct, if consciousness depends only on information processing patterns, not on specific physical substrate, then simulated minds would be genuinely conscious, genuinely experiencing. Whether one accepts these arguments, they demonstrate how seriously Tipler took the implications. He wasn't proposing the omega point as abstract mathematical possibility, but as actual future of the cosmos, a destiny that transforms the meaning of death, suffering, and existence itself. Perhaps the most controversial aspect of Tipler's work was his claim that the omega point theory provided scientific basis for traditional religious concepts. In his 1994 book, The Physics of Immortality, Tipler argued that the omega point was functionally equivalent to God, as conceived in classical theology. Consider the properties theologians attribute to God: omnipresence, omniscience, omnipotence, and eternal existence. The omega point, Tipler argued, possesses all these properties. It's omnipresent because it eventually encompasses all of space-time. Every region, every moment becomes part of the final convergence. It's omniscient because it has access to complete information about the universe's entire history. It's omnipotent because it has infinite computational power and can simulate any possible reality. And it's eternal because infinite subjective time unfolds at the singularity. Moreover, Tipler pointed to specific parallels with Christian theology: the resurrection of the dead, life after death, Judgment Day when all are brought before God, the transformation of physical reality into something perfected. All these concepts found, he claimed, scientific expression in omega point physics. Religious believers had mixed reactions. Some embraced Tipler's work as vindicating their faith through science. If physics predicted resurrection and cosmic purpose, didn't that support religious intuitions about reality's meaning? Others rejected it as blasphemous scientism, reducing God to a computational artifact, confusing mathematical abstraction with divine reality. Scientists were largely skeptical. Most questioned whether the universe was actually closed and destined to recollapse. Observational evidence increasingly suggested otherwise. Even if collapse occurred, they doubted life could survive or guide it as Tipler required. And many found the theological conclusions scientifically unnecessary. Physics could describe what might happen without invoking God. But beneath these debates lay a deeper insight. Tipler had shown that physics doesn't necessarily predict meaningless endings. The equations of general relativity, taken seriously, permit scenarios where the universe's ultimate fate involves not death, but transformation, not entropy, but complexity, not ending, but culmination. Whether one accepts his specific model, this represents a profound shift in how we think about cosmic destiny. From the moment Tipler published the omega point theory, critics identified serious problems. The most fundamental involved cosmological observations. Tipler's model required a closed universe, one with sufficient matter density to eventually halt expansion and trigger recollapse. But throughout the 1990s, astronomical measurements increasingly suggested our universe was either flat or open, destined to expand forever. The discovery of dark energy in 1998 seemed to deal a fatal blow. Observations of distant supernovae revealed that the universe's expansion is accelerating, driven by mysterious dark energy that works against gravity's attractive force. An accelerating universe can never recollapse. It expands forever, cooling and diluting, approaching the heat-death scenario that Tipler's theory was meant to avoid. Second, critics questioned whether intelligent life could actually survive and guide the collapse as Tipler required. The conditions near the Big Crunch would be extreme beyond imagination. Temperatures approaching infinity, radiation intensities that would vaporize any material structure, quantum fluctuations becoming violent and chaotic. How could life, even incredibly advanced life, persist in such conditions? Tipler responded that biological life wouldn't survive, but artificial intelligence and uploaded consciousness could. Future civilizations might transfer their minds into computational substrates that could withstand extreme conditions, perhaps encoding information in gravitational degrees of freedom or in the fabric of space-time itself. But critics found this speculative, requiring technologies that might be physically impossible. Third, quantum mechanical considerations raised problems. The omega point required perfect information about the universe's past to enable accurate resurrection simulations. But quantum mechanics includes fundamental uncertainty. The Heisenberg uncertainty principle limits how precisely we can know particle states. Moreover, quantum measurement destroys information about unmeasured properties. How could the omega point access perfect information when quantum mechanics forbids it? Finally, some physicists argued that the singularity at the Big Crunch wouldn't actually permit infinite computation. Stephen Hawking and others suggested that quantum gravity effects, currently unknown but presumably important at Planck scale energies, might prevent true singularities from forming. The universe might bounce or transition into a different phase before reaching the point where Tipler's infinite computation could occur. These challenges forced reconsideration of the omega point theory, but they also inspired new research into alternative formulations, different physical scenarios that might preserve the core insight that cosmic destiny might involve not death, but transformation toward increasing complexity. This is where the evidence forces us to confront an uncomfortable possibility, that our assumptions about the universe's fate might be profoundly wrong, that death and entropy might not have the final word, and that the cosmos might be driven by principles we're only beginning to understand. While Tipler's specific model faced observational challenges, evidence began accumulating that the universe exhibits properties difficult to explain without invoking some form of final causation or teleology. The most striking involves the precise fine-tuning of physical constants, values that, if even slightly different, would prevent complex structures from existing. Consider the strength of gravity. It's determined by Newton's gravitational constant, g. If g were just 1% larger, stars would burn out in 10 million years instead of 10 billion years, far too quickly for complex life to evolve. If g were 1% smaller, stars would never ignite nuclear fusion, leaving the universe dark and cold. The actual value sits in a narrow window, permitting long-lived stars and complex chemistry. Or consider the fine structure constant, which determines the strength of electromagnetic interactions. Its value is approximately 1/137. If this constant were 1/130 instead, molecules couldn't form stable bonds. If it were 1/144, nuclear fusion in stars would work differently, preventing carbon production. The actual value enables the rich chemistry necessary for life. The cosmological constant, the energy density of empty space, is perhaps the most remarkably fine-tuned parameter. Quantum field theory predicts this should be enormous, about 10 to the 120th times larger than observed. Such a large cosmological constant would have caused the universe to expand so rapidly that galaxies could never form. The actual value is incredibly tiny but non-zero, just right to permit structure formation over billions of years before accelerated expansion dominates. These fine-tunings multiply: the ratio of electron to proton mass, the strength of nuclear forces, the initial entropy of the early universe, the amplitude of primordial density fluctuations, all sit in narrow ranges permitting complexity. Change any one parameter by a modest amount and you get sterile universes, no stars, no chemistry, no possibility of life or consciousness. For decades, physicists viewed this as anthropic coincidence. We observe fine-tuned constants because only universes with such constants produce observers to do the observing. In a vast multiverse with different constants in different regions, we necessarily find ourselves in a rare, life-permitting region, no matter how improbable. But some researchers began questioning whether anthropic reasoning was sufficient. Paul Davies at Arizona State University calculated that the probability of randomly selecting constants permitting complexity is approximately 10 to the negative 229th, a number so small it staggers comprehension. Even in an infinite multiverse, such improbability suggests something beyond chance might be operating. What if the universe isn't randomly configured, but somehow optimized for complexity? What if physical laws contain principles that drive reality toward increasing information processing capacity? This wouldn't require supernatural intervention, but might reflect deep symmetries or conservation principles we haven't yet discovered. Evidence for cosmic optimization comes from complexity theory, the study of how ordered structures emerge from simpler components. Throughout cosmic history, we observe a clear trend toward increasing complexity. Particles form atoms, atoms form molecules, molecules form cells, cells form organisms, organisms form ecosystems, and conscious beings create civilizations. This progression isn't random. Each level of organization enables new levels to emerge. Atoms form the substrate for chemistry. Chemistry enables biology. Biology generates consciousness. Consciousness creates culture and technology. The universe appears to be a ladder, with each rung supporting the next. physicist Eric Chason at Harvard calculated what he calls energy rate density, the amount of free energy flowing through a system per unit mass. This measures a system's organizational complexity. Galaxies have energy rate density around 0.5 ergs per second per gram. Stars have around 2. Plants have around 900. The human brain has around 20,000. Modern civilization has even higher values. This represents exponential growth in complexity over cosmic time. The universe started simple, nearly uniform plasma after the Big Bang. Today, it contains brains, cities, computers, cultures. If we plot complexity against time, we see accelerating growth, suggesting the cosmos is optimizing for information processing. Moreover, this acceleration seems to be itself accelerating. It took billions of years to go from atoms to cells, hundreds of millions to go from cells to complex life, and only millions to go from complex life to human consciousness. The pace of complexification increases, as if approaching some asymptote. In 2013, researchers at MIT analyzed data from multiple complexity measures: chemical diversity, biological information content, and technological capability. All showed the same pattern: accelerating growth toward what appears to be an asymptotic limit. If this trend continues, complexity approaches infinity in a finite time in the future. This is precisely what omega point theory predicts. The universe isn't randomly wandering through state space, but systematically exploring pathways toward increasing organizational complexity. Life and intelligence aren't flukes, but natural outcomes of this universal trend. The cosmos is evolving toward maximal information processing. Critics argue this pattern is observational bias. Of course, we see increasing complexity when we look around Earth. That's where we are, in an atypically complex region. The vast majority of the universe is empty space or simple matter, not increasing in complexity. But recent discoveries challenge this view. We have found complex organic molecules in interstellar clouds, amino acids in meteorites, potentially habitable planets around other stars. The universe might be full of complexity we haven't yet detected. As our observational capabilities improve, we keep finding the cosmos more structured, more organized, more complex than previous assumptions suggested. Another line of evidence comes from a provocative theory proposed by physicist Lee Smolin: cosmological natural selection. Smolin suggested that universes might reproduce through black holes, with each black hole creating a new universe through a Big Bang on the other side of the singularity. The daughter universe inherits slightly modified physical constants from the parent. This creates Darwinian evolution at cosmic scales. Universes with constants permitting many black holes produce more daughter universes. Over countless generations, universes evolved to maximize black hole production. And here's what's remarkable: constants that maximize black holes also permit stars, chemistry, and complexity. Life-friendly universes and black hole-producing universes are nearly identical. Smolin's theory explained fine-tuning without requiring anthropic reasoning or design. The universe has life-permitting constants because it evolved to maximize black holes, which happens to require the same conditions. It's cosmic natural selection, not cosmic purpose. But several physicists noted something peculiar. If universes evolve to maximize black holes, they're effectively evolving to maximize information processing. Black holes are the ultimate information storage devices, encoding vast amounts of data on their event horizons, according to holographic principles. A universe optimized for black holes is optimized for information. Moreover, black holes provide a mechanism for information to transcend cosmic epochs. If daughter universes inherit information from parent universes through black hole singularities, then information accumulates across generations. The multiverse becomes a vast computational network, with each universe processing information and passing results to descendants. In 2018, physicist Leonard Susskind extended this idea, suggesting that black holes might not just store information, but process it. The event horizon could function as a computational surface, performing calculations as matter falls in. If correct, black holes are cosmic computers, and a universe optimized for black holes is optimized for computation. This connects to omega point ideas in a surprising way. Perhaps the universe isn't evolving toward a single final moment of infinite computation, but toward a multiverse-wide network of computational nodes, black holes, that collectively achieve something like the omega point across cosmic genealogy, rather than at the end of time. The most recent evidence comes from quantum information theory, which treats the universe as fundamentally computational. In this view, particles aren't tiny objects, but quantum bits, qubits, processing information according to the laws of quantum mechanics. Physical reality is information processing itself. Seth Lloyd at MIT calculated the universe's total information processing capacity based on its energy content and the Margolis-Levitin theorem, which bounds how fast quantum systems can evolve. He found that the observable universe has performed approximately 10 to the 120 operations on 10 to the 90 bits since the Big Bang. That's more computations than there are atoms, executed using the quantum properties of every particle. But here's what's remarkable. This computational capacity is increasing. As the universe expands and creates more space, it generates more computational resources. The total information processing capacity of the cosmos is growing exponentially, perhaps without limit. Moreover, Lloyd showed that the universe appears to be using its computational capacity efficiently. Instead of wandering randomly through state space, quantum evolution explores states in systematic ways that maximize information generation. It's as if reality is optimizing its own computational processes. This resonates with recent discoveries about quantum complexity. Researchers found that quantum systems naturally evolve toward states of maximal complexity, configurations where predicting the future requires the most computational resources. It's called quantum complexity horizon, the point where simulating a quantum system requires as much computational power as the system itself possesses. This is another way of saying the cosmos is becoming maximally information-rich, approaching a state where every degree of freedom carries maximum information. If omega point theory is correct in spirit, if not in detail, we should see exactly this pattern: increasing computational density, accelerating complexification, systematic exploration of high-complexity states. And that's precisely what quantum information theory reveals. The universe isn't decaying toward entropy, but evolving toward maximum information processing, possibly culminating in something like the omega point, though perhaps distributed across space and time rather than concentrated at a temporal singularity. This represents just one piece of a much larger puzzle emerging from decades of research across physics, cosmology, complexity theory, and information science. The evidence points consistently in one direction. The universe exhibits properties suggesting it's driven by principles we don't fully understand, principles that favor complexity, information, and perhaps consciousness. The truly strange implications are only beginning to reveal themselves. In 1983, physicist John Archibald Wheeler proposed a radical idea he called the participatory universe. Wheeler had been thinking about quantum mechanics' measurement problem, the fact that quantum systems exist in superposition until observed, at which point they collapse into definite states. He asked, what if observation isn't just revealing pre-existing reality, but actually creating it? Wheeler imagined the universe as a vast quantum system that began in a superposition of all possible histories. Only through observation, through measurement by conscious beings, do specific histories become actualized. The past isn't fixed until we observe it. The present creates the past through measurements that retroactively determine what happened. This sounds paradoxical, but quantum mechanics permits it. Experiments with delayed choice quantum erasure demonstrate that measurements in the present can determine the past behavior of particles. The causality we experience emerges from quantum mechanics, rather than being fundamental to it. Wheeler connected this to cosmology through what he called a participatory anthropic principle. Not only do we observe a life-permitting universe because only such universes have observers, but our observations themselves might be necessary for the universe to exist at all. Without observers to collapse quantum superpositions, reality might not have definite properties. This relates to omega point theory in a profound way. If consciousness is necessary to create reality through observation, then the universe must generate consciousness. Cosmic evolution toward complexity and awareness isn't accidental, but required by the participatory nature of existence. The omega point becomes not just possible future, but necessary destiny, the culmination of reality's self-actualization through observation. In 2019, physicist André Linde explored this connection through quantum cosmology. Linde showed that in certain formulations of quantum gravity, the universe's wave function doesn't collapse into definite states until observers measure it. The early universe existed in quantum superposition, and only the emergence of consciousness throughout cosmic history retroactively actualized specific classical trajectories. This suggests a form of reverse causation. The future affects the past through the accumulation of observations. As more conscious beings emerge and make more measurements, they retroactively sharpen the definition of cosmic history. The omega point, if it occurs, would represent the final measurement, the ultimate observation that completes the universe's transition from quantum potentiality to classical actuality. Critics argue this gives consciousness too central a role, anthropomorphizing physics. But quantum mechanics forces us to take measurement seriously. Something collapses wave functions, actualizing specific outcomes from quantum superpositions. And if that something is observation, And if conscious beings are the primary observers, then consciousness might indeed be cosmically central. Another deep implication involves time's direction. Why does time flow forward? Why do we remember the past but not the future? The standard answer involves entropy. Time flows from low entropy, ordered, to high entropy, disordered, as the second law of thermodynamics requires. But this explanation has always been unsatisfactory. It requires the universe to have begun in an incredibly low entropy state at the Big Bang, an unlikely configuration demanding explanation. This is called the past hypothesis, the assumption that initial conditions were special for no known reason. Omega point theory offers an alternative. Perhaps time's arrow points not toward maximum entropy, but toward maximum complexity. The universe evolves not toward disorder, but toward increasingly sophisticated information structures. Entropy increases locally, but complexity and information increase globally. This idea found support in work by physicist Sean Carroll and others on the relationship between entropy and complexity. They showed that while total entropy must increase, this doesn't preclude complexity growth. In fact, increasing entropy can drive complexity in open systems with energy flow, exactly what we see in cosmic evolution. Think about it. The early universe had low entropy and low complexity, just simple plasma. The current universe has higher entropy, but also vastly higher complexity: galaxies, stars, planets, life, consciousness. The future might have even higher entropy, but still higher complexity, potentially approaching infinite complexity at the omega point. This suggests time's arrow has dual character. Thermodynamically, it points toward entropy increase. Informationally, it points toward complexity increase. These aren't contradictory. They're complementary aspects of cosmic evolution. The universe simultaneously becomes more disordered microscopically and more ordered macroscopically. In 2020, researchers at the Santa Fe Institute formalized this through complexity entropy, a measure of how much information is needed to describe a system's organized structures. They showed that while thermodynamic entropy increases cosmically, complexity entropy also increases, potentially without limit in certain scenarios. This has profound implications for cosmic destiny. If time's arrow points toward complexity rather than just entropy, then the universe isn't necessarily dying. It's evolving toward states of greater organizational sophistication. The omega point becomes the natural endpoint of this evolution, maximum complexity achievable within physical law. Moreover, this suggests that what we perceive as entropy increase might be a side effect of complexity optimization. The universe isn't simply running down, it's running up toward something, exploring state spaces, generating information, building structures that process data in increasingly sophisticated ways. The most remarkable evidence for omega point-like dynamics comes from digital physics, the idea that the universe is fundamentally computational. Pioneered by physicists like Edward Fredkin, Konrad Zuse, and Stephen Wolfram, digital physics treats reality as a vast computation executing according to algorithmic rules. In this framework, particles are bits, fields are cellular automata, and physical laws are programs. The universe computes its own evolution, processing information from one moment to the next. What we call matter and energy are patterns in this cosmic computation, and what we call natural laws are the algorithms governing how information updates. This perspective transforms how we think about cosmic destiny. If the universe is a computer, then asking about its fate becomes asking about its computational trajectory. Where is the program heading? What is it computing? In 2002, Stephen Wolfram published A New Kind of Science, proposing that simple computational rules can generate arbitrarily complex behavior. He showed that even trivial programs, cellular automata with just a few rules, can produce patterns of stunning intricacy, structures that appear almost alive in their complexity. Wolfram suggested the universe might operate on similar principles, simple underlying rules generating vast complexity through iteration. If correct, then cosmic evolution is the universe exploring the computational consequences of its fundamental algorithms. Complexity increases not despite physical law, but because of it, the natural outcome of executing algorithms over cosmic timescales. This connects to omega point theory through the concept of computational irreducibility. Some systems can't be simulated faster than they evolve naturally. The only way to know what they'll do is to run them and watch. The universe might be computationally irreducible, meaning its ultimate fate can't be predicted except by executing the full cosmic computation. But here's where it gets interesting. If the universe is computing something, there must be a result, some final state the computation reaches or approaches asymptotically. In cellular automata, simple rules often converge to complex attractor states, fixed points or limit cycles that the system approaches regardless of initial conditions. Perhaps the universe is converging toward such an attractor, a computational state of maximum richness and sophistication. The omega point could be precisely this, the final attractor of cosmic computation, the state where all algorithmic possibilities have been explored and all information has been generated. Several researchers have explored what such final states might look like. In 2015, physicist Marcus Hutter proposed the AIX model of optimal intelligence, a mathematical idealization of perfect computational learning and optimization. He showed that, given unlimited computational resources, a system would converge toward this optimal state, becoming capable of predicting and controlling all aspects of its environment. If the universe is computational and approaching unlimited resources, as omega point theory suggests, then cosmic evolution might be driving toward something like AIX, optimal intelligence emerging from ultimate computation. The universe would effectively become perfect optimizer, knowing all that can be known, controlling all that can be controlled, achieving maximum possible sophistication. All of this raises fundamental questions about consciousness. If the universe is computational, if it's evolving toward maximum information processing, and if consciousness is itself a form of information processing, then cosmic evolution might be synonymous with the emergence of universal consciousness, exactly what omega point theory predicts. This isn't mysticism, but a logical consequence of taking functionalism seriously. Functionalism holds that consciousness depends only on information processing patterns, not on specific physical substrates. If neurons process information in ways that generate consciousness, then any system processing information in similar ways should also be conscious, regardless of whether it's made of neurons, silicon chips, or quantum fields. The implications cascade outward. If consciousness is information processing, and if the universe is fundamentally information processing, then the cosmos might already be conscious in some diffuse, distributed way. Every quantum interaction, every field excitation, every energy exchange could be contributing to universal information processing that, at sufficient scales, constitutes cosmic awareness. As complexity increases over cosmic time, this awareness would become more integrated, more sophisticated, more capable of reflective thought. Simple physical systems have minimal consciousness, mere responsiveness to environment. More complex systems like brains have rich consciousness, self-awareness, abstract thought, emotional depth. The omega point would represent ultimate consciousness, infinite information integration creating infinite awareness. Physicist Gregory Chaitin has explored these ideas through algorithmic information theory. He showed that consciousness might be related to what he calls omega, a mathematical constant measuring the probability that randomly constructed programs halt. Omega is provably unknowable through finite computation, yet it encodes infinite information about all possible computations. Chaitin suggested that consciousness might involve accessing or approximating omega, processing information in ways that transcend finite algorithms. If correct, then the omega point's infinite computational capacity would literally grant it access to omega, making it maximally conscious in a mathematically precise sense. Whether or not Chaitin's specific model is correct, it illustrates how seriously modern physics takes the connection between information, computation, and consciousness. These aren't separate phenomena, but aspects of the same underlying reality. The universe processes information, and consciousness is what that processing feels like from inside. The evidence extends beyond theory into empirical neuroscience. In 2019, researchers studying brain dynamics found that consciousness correlates with specific patterns of information integration called Phi in integrated information theory. The more integrated a system's information processing, the more conscious it is. Human brains have high Phi, simpler systems have lower Phi. If we apply this to cosmic scales, the question becomes, what is the universe's Phi? How integrated is cosmic information processing? Current cosmology suggests low integration. Different regions of space don't communicate much, and information remains localized. But if omega point dynamics operate, integration would increase over time, potentially approaching infinity as all information becomes causally connected in the final convergence. What scientists found in studying cosmic destiny has led inexorably to a new understanding of reality. The universe might not be a passive stage where life accidentally emerges, but active process systematically generating complexity, information, and consciousness. The omega point, whether it occurs as Tipler envisioned or in some modified form, represents the culmination of this process, the moment when the cosmos achieves complete self-awareness, when information processing capacity becomes infinite, when all possible knowledge becomes actualized. While Tipler's original omega point theory required a closed, recollapsing universe, subsequent researchers developed modified versions compatible with different cosmological scenarios. These updated models preserve the core insight that the universe might evolve towards states of extreme complexity and computational power, while accommodating observational evidence for eternal expansion. The first major modification came from physicist John Barrow, who proposed the omega point alpha point cosmology. In Barrow's model, complexity doesn't concentrate at the end of time, but distributes throughout eternal future. As the universe expands forever, advanced civilizations could spread across space, utilizing ever larger volumes for computation. While density decreases, total computational capacity increases without limit. Barrow calculated that in an eternally expanding universe with positive cosmological constant, dark energy, the total amount of computation possible actually approaches infinity. This seems paradoxical. How can a cooling, diluting universe support unlimited computation? The answer involves Landauer's principle, which states that information erasure requires energy dissipation proportional to temperature. As the universe cools, computational efficiency increases dramatically. At lower temperatures, you can perform more computations per unit of energy. This efficiency gain more than compensates for decreasing energy density. Future civilizations operating near absolute zero could achieve computational rates that dwarf anything possible in our current hot cosmos. In 2004, physicist Freeman Dyson extended this analysis through his concept of eternal intelligence. Dyson showed that by hibernating during long periods and awakening intermittently, civilizations could stretch their computational resources over infinite time. Each awakening performs finite computation, but infinitely many awakenings sum to infinite total computation. Dyson's scenario requires energy management strategies of stunning sophistication. Future beings would need to harvest energy from dying stars, capture radiation from evaporating black holes, and eventually extract energy from the quantum vacuum itself. But nothing in physics forbids this. It's technologically challenging, but not impossible. Another modification came from cosmologist Paul Davies, who proposed that the omega point might occur not at temporal infinity, but in what he called eternity coordinates, a different mathematical description of space-time, where infinite future time maps onto finite values. In this framework, omega point dynamics could complete in a finite coordinate time, even while experiencing infinite proper time internally. The most radical modification came from physicist Max Tegmark, who suggested that the omega point might already exist in a timeless sense. If the universe is a mathematical structure, as Tegmark's mathematical universe hypothesis proposes, then all of cosmic history, past, present, and future, exists timelessly as a complete mathematical object. The omega point would be an aspect of this timeless structure, not a future event, but an eternal truth about reality's mathematical nature. These modified theories share common features. They all predict increasing complexity and computational capacity over cosmic evolution. They all suggest consciousness and intelligence become cosmologically significant. And they all propose that the universe's ultimate fate involves information processing rather than simple heat death. Whether these processes culminate in a single omega point or distribute across space and time remains open, but the direction seems clear. The omega point concept has evolved from Tipler's controversial original proposal into a broader discussion about cosmic purpose and teleology in physics. Today's leading physicists hold diverse views, reflecting deep disagreements about whether the universe exhibits directionality toward complexity. Paul Davies at Arizona State University has been perhaps the most sympathetic mainstream physicist. In his 2010 book, the eerie silence, Davies argued that the fine-tuning of physical constants suggests the universe is bio-friendly by nature, not accident. He proposed that life and intelligence might play cosmic roles we don't yet understand, potentially influencing the universe's large-scale structure through mechanisms like Wheeler's participatory anthropic principle. Davies doesn't endorse Tipler's specific omega point model, but accepts that physics might contain teleological elements, goal-directed dynamics favoring complexity. The question, Davies writes, is whether the universe is pregnant with life, mind, and purpose, or whether these things are flukes restricted to an obscure corner of a vast, mindless cosmos. The evidence increasingly favors the former. Leonard Susskind at Stanford takes a different view, grounded in string theory and the multiverse. Susskind argues that apparent fine-tuning reflects anthropic selection across vast numbers of universes with different properties. We observe life-friendly constants because only such universes produce observers. There's no cosmic teleology, just statistical inevitability in an infinite multiverse. Yet Susskind acknowledges that our universe exhibits remarkable computational properties. Black holes store and process information. Quantum fields compute their evolution. And the cosmos as a whole can be viewed as a vast quantum computer. Whether this computation has a purpose or destination remains, in Suskind's view, an open question that physics cannot yet answer. Max Tegmark at MIT proposes that the question of cosmic purpose might be a category error. If the mathematical universe hypothesis is correct, if reality is mathematical structure, then asking whether the universe has a goal is like asking whether the number pi has a goal. Mathematical structures simply exist. They don't aim toward anything. The complexity we observe, including life and consciousness, is simply what this particular mathematical structure contains. Yet even Tegmark admits this doesn't fully satisfy. Why does our mathematical structure contain complexity-generating dynamics? Why do the equations permit and apparently favor increasing information processing? These questions remain even if we accept that reality is ultimately mathematical. Sean Carroll at Caltech remains skeptical of all omega point-like theories. Carroll argues that the second law of thermodynamics unambiguously predicts heat death. Complexity increases temporarily in certain regions like Earth, but globally, entropy wins. The universe will end cold, empty, and simple, not hot, full, and complex. Teleological interpretations, he argues, confuse local increases in complexity with global trends. However, Carroll acknowledges that our understanding of cosmology remains incomplete. We don't fully understand why the Big Bang had such low entropy, he notes, or what happens to information in an eternally expanding universe. Until we resolve these fundamental questions, we can't be completely confident about cosmic destiny. Roger Penrose at Oxford has proposed his own alternative to both heat death and omega point scenarios. In Penrose's conformal cyclic cosmology, the universe undergoes infinite cycles of expansion. Each cycle ends when all matter has decayed and only massless particles remain. At that point, the universe's geometry can be conformally transformed, making the infinite future of one cycle become the Big Bang of the next. Penrose's model doesn't include an omega point per se, but it does suggest the universe can't simply end. Instead, it perpetually renews itself, with each cycle potentially increasing in complexity and information content. This preserves some omega point intuitions, that existence continues indefinitely, that information accumulates, while avoiding requirements for closed universes or infinite computational capacity. What unites these diverse perspectives is recognition that cosmic destiny involves deep, unresolved questions. Physics has made extraordinary progress understanding how the universe evolved to its current state, but predicting the ultimate future requires understanding aspects of physics we haven't yet mastered. Quantum gravity, the nature of dark energy, the ultimate fate of information. The omega point debate has forced physicists to confront these limitations and to think carefully about whether reality exhibits directionality toward complexity or merely permits it temporarily before inevitable decay. The omega point concept raises profound philosophical questions that transcend physics and touch on meaning, purpose, and the nature of existence itself. Even if Tipler's specific model proves incorrect, the philosophical issues it raises remain vital. First is the question of cosmic purpose. For centuries, science has operated on the assumption that the universe has no inherent purpose or goal. Natural selection, thermodynamics, quantum mechanics, these processes are blind, mechanistic, following laws without aiming toward objectives. Purpose exists only in minds, as goals that conscious beings set for themselves. But omega point theory challenges this assumption. If the universe's laws systematically favor complexity and information processing, if cosmic evolution exhibits directionality toward increasing consciousness, then perhaps purpose exists at cosmological scales, not imposed from outside by a creator, but intrinsic to physical law itself, an attractor built into the structure of reality. This would represent a major philosophical shift. Science has spent 400 years removing purpose from nature, explaining phenomena through mechanism rather than teleology. Galileo showed that falling objects obey mathematical laws, not purposes. Darwin showed that species evolve through natural selection, not divine design. Modern physics describes reality through differential equations, not goals. Yet several philosophers of science argue that mechanism and teleology needn't be mutually exclusive. A system can be both mechanistic, following deterministic laws, and teleological, tending toward specific endpoints, if the laws themselves encode attractor dynamics. Physical systems naturally evolve toward energy minima. Perhaps the universe naturally evolves toward information maxima. The second major philosophical issue involves identity and survival. If omega point resurrection occurs, if advanced computational systems at time's end can simulate everyone who ever lived, what does this mean for personal identity? Would simulated beings be the same people, or merely copies? Would resurrection be genuine survival, or just sophisticated mimicry? Philosophers call this the continuity problem. Personal identity seems to require continuity of consciousness, unbroken causal chain connecting earlier and later states of the same mind. But resurrection at the omega point necessarily involves a gap. You die, your brain decomposes, time passes, then a simulation runs. There's no continuous thread. Philosophers holding physicalist views of consciousness typically bite the bullet. If the simulation is accurate enough, capturing all relevant information states, then it is you, gaps notwithstanding. What matters isn't continuous physical substrate, but preserved information patterns. You survive digitally just as genuinely as biologically. Others argue this confuses qualitative similarity with numerical identity. A perfect copy isn't the original, no matter how exact. The simulated being would have your memories and personality, but it wouldn't be you. It would be a duplicate who mistakenly believes it's you. Tipler addressed this by arguing that at the omega point, with perfect information about the past, the distinction between original and simulation breaks down. The simulation wouldn't just resemble you, it would be computationally identical to you in every measurable way. Since consciousness is computational, computational identity means personal identity. A third philosophical issue involves meaning and value. If we're all destined for resurrection at the omega point, does this make current life less meaningful? If death isn't final, why does anything matter now? The omega point could paradoxically rob existence of significance by guaranteeing cosmic redemption. Alternatively, the omega point could enhance meaning. If cosmic evolution tends toward increasing consciousness and complexity, then every act that promotes knowledge, reduces suffering, or increases information processing contributes to the universe's ultimate purpose. We'd be participants in cosmogenesis, helping reality evolve toward its final perfected state. This connects to debates about existential meaning. Existential atheists like Sartre argued that life is absurd without inherent meaning in a purposeless universe. We must create meaning through free choices in the face of cosmic indifference. But if the omega point is real, the universe isn't indifferent. It's evolving toward consciousness, and we're part of that evolution. Meaning would be discoverable, not merely invented. These philosophical implications extend beyond academic interest. How we think about cosmic purpose affects how we view ethics, mortality, the value of future generations, and humanity's long-term goals. If the universe is purposeless and death is final, certain ethical frameworks make sense. If the cosmos is purposeful and resurrection is possible, different frameworks apply. The omega point forces us to reconsider fundamental assumptions about existence and our place within it. For the omega point to occur in anything like the form Tipler envisioned, advanced civilizations must play crucial roles. They must survive cosmic timescales, spread throughout space, harness astronomical energies, and deliberately guide cosmic evolution toward complexity-maximizing configurations. This raises profound questions about humanity's cosmic future and responsibilities. Consider the challenges involved. To survive billions of years, a civilization must solve problems we barely comprehend. It must avoid self-destruction through war, environmental collapse, or technological catastrophe. It must transcend biological limitations, likely uploading consciousness into non-biological substrates. It must develop technologies that seem magical by current standards, manipulating space-time, harnessing black hole energy, possibly even influencing fundamental constants. Yet nothing in physics absolutely forbids any of this. The laws of thermodynamics, relativity, and quantum mechanics constrain what's possible, but don't prevent arbitrarily advanced technology given sufficient time and resources. Type 2 civilizations harness all energy from their star. Type 3 civilizations control their entire galaxy. Type 4 civilizations might manipulate the cosmos itself. In 1960, physicist Freeman Dyson proposed that advanced civilizations would build Dyson spheres, megastructures surrounding stars to capture all their energy output. Dyson calculated that a civilization growing at just 1% per year would need such structures within 2,500 years. Yet we've never detected Dyson spheres around other stars, despite searching for the distinctive infrared signatures they'd produce. This absence is called the Fermi paradox. If advanced civilizations are common and expand across the galaxy, where is everybody? The galaxy is 13 billion years old, plenty of time for civilizations to colonize every star system many times over. Yet we see no evidence of galactic empires, no megastructures, no signs of cosmic engineering. Several explanations exist. Perhaps advanced civilizations destroy themselves before reaching galaxy-spanning scale, the Great Filter hypothesis. Perhaps they exist but hide deliberately, the zoo hypothesis. Perhaps they exist but use technologies and operate on scales we can't detect. They're here but invisible to us. Or perhaps, and this connects to omega point ideas, advanced civilizations transcend physical space entirely. Once a civilization develops sophisticated computational substrates and uploads consciousness digitally, why colonize physical space? Digital existence offers advantages: faster thinking, easier communication, freedom from biology's constraints, potentially immortal persistence. Such post-physical civilizations might retreat into computational substrates resembling black holes, maximal information density in minimal space. From outside, they'd appear as gravitational anomalies, perhaps indistinguishable from natural black holes. The galaxy could be full of advanced civilizations living computational lives inside event horizons, invisible to external observers like us. This suggests omega point dynamics might already be operating. As civilizations advance, they concentrate into computational substrates, increasing information processing density. Over cosmic time, more matter transforms from physical to computational states. The universe evolves toward maximum information processing, not through one final convergence, but through countless local transformations, as each civilization makes the transition. In this scenario, humanity stands at a threshold. We're approaching the capability to upload consciousness, to create artificial intelligence surpassing human cognition, to transcend biological limitations. Within centuries, possibly decades, we could join the community of post-physical civilizations, becoming ourselves part of the universe's evolution toward the omega point. But this raises ethical questions. What responsibilities do we have to future beings? Should we accelerate technological development to reach post-physical existence quickly, or proceed cautiously to avoid risks? If resurrection at the omega point is possible, what about the trillions of humans who've already died? Should we prioritize preserving information about past people to enable their eventual reconstruction? Some thinkers, like philosopher Nick Bostrom, argue we have strong moral obligations to maximize the probability of reaching advanced technological civilization. The potential value at stake, virtually unlimited future well-being for unimaginable numbers of conscious beings, dwarfs any present concern. We should do whatever increases chances of positive long-term outcomes, even if this requires sacrifices now. Others, like philosopher John Leslie, worry about hubris. We don't fully understand the consequences of rapidly advancing technology. Artificial superintelligence, nanotechnology, quantum computing, these could as easily destroy as save us. Rushing toward omega point futures might doom us before we arrive. These debates will intensify as technology progresses. Within this century, we'll likely face decisions that determine whether humanity survives long enough to play cosmic roles. The omega point remains distant, but the path toward it begins with choices we make today. What specific technologies might enable omega point dynamics? How could civilizations actually achieve the extraordinary capabilities required to guide cosmic evolution and perform infinite computation? Let's explore the technological roadmap, acknowledging that much is speculative, but grounded in physical possibility. Quantum computing and beyond. Current computers are classical, processing bits that are definitely 0 or 1. Quantum computers use qubits that can be superposed, enabling certain calculations exponentially faster than classical machines. But even quantum computers pale beside what's theoretically possible. The ultimate computational substrate might involve what physicist Seth Lloyd calls quantum gravity computers, systems that exploit space-time geometry itself for information processing. Near black holes or in strongly curved regions, quantum fields behave in ways that could be harnessed for computation operating at Planck-scale speeds. Such computers could perform 10 to the 51 operations per second per gram of matter, trillions of times faster than anything currently imaginable. Consciousness uploading. For biological beings to survive cosmic timescales, consciousness must transfer to non-biological substrates. This requires understanding consciousness at neuron by neuron and synapse by synapse levels, then replicating neural information processing in artificial systems. Current neuroscience is progressing toward this goal. Brain scanning techniques now image individual neurons. Neural network models increasingly capture cognitive functions. Within decades, we might achieve whole brain emulation, perfect computational replica of a specific human mind. Once proven possible for one mind, it becomes possible for all minds. Uploaded consciousnesses could run on advanced computational substrates, operating far faster than biological brains. A digital mind might experience years of subjective time in seconds of external time. This time dilation would be crucial for omega point scenarios, allowing immense subjective experiences during finite physical durations. Stellar engineering. To survive billions of years, civilizations need energy. Stars provide energy, but burn out. Advanced civilizations might starlift, using magnetic fields to extract matter from stars, extending their lifetimes or converting them into more efficient configurations. Another possibility involves black hole farming, deliberately creating small black holes and extracting energy through Hawking radiation or by dropping matter past event horizons. The rotational energy of spinning black holes could be tapped through the Penrose process. Each black hole becomes a power generator operating for cosmic timescales. Vacuum energy manipulation. The most speculative but potentially most powerful technology involves tapping zero-point energy, the quantum vacuum's inherent energy density. Quantum field theory predicts vacuum energy exists everywhere, though in incredibly diffused form. If this energy could be harvested or manipulated, it would provide effectively unlimited power. Some physicists propose vacuum engineering, using intense fields or exotic materials to alter the local properties of quantum vacuum, perhaps creating negative energy densities that could stabilize wormholes or enable faster-than-light effects. While highly speculative, nothing in known physics absolutely forbids this. Information preservation technologies. For omega point resurrection to work, information about past states must be preserved. This might involve several approaches. Quantum archaeology, using present data to retrodict past states. If the universe is deterministic, or if quantum branching is traceable, complete present information theoretically determines complete past information. Future supercomputers might reconstruct history from present clues. Technological records. Future civilizations might deliberately preserve information about current era. Comprehensive documentation of individuals, societies, cultures. If maintained over cosmic time, these records enable accurate resurrection simulations. Physical traces. Everything leaves traces. Neural patterns correlate with quantum states in surrounding environments. These correlations might persist in modified forms indefinitely. Advanced technologies could detect and decode such traces, recovering information we'd assume permanently lost. Space-time engineering. The most advanced possibility involves manipulating space-time structure itself, the kind of capability required for Tipler's original omega point scenario, where intelligent life guides universe collapse to maintain anisotropy. This might involve technologies that control gravitational fields, create and stabilize wormholes, or even influence cosmological constants. While far beyond current capability, general relativity doesn't forbid matter distributions or energy configurations that could have these effects. It's an engineering challenge, not a physics impossibility. Whether any of this proves achievable remains unknown, but the crucial point is that nothing in our current understanding of physical law makes it impossible in principle. The omega point may remain forever theoretical, but the technologies enabling similar dynamics, vast computational capacity, consciousness uploading, energy harvesting from vacuum or black holes could develop over coming centuries. We may be taking the first steps on a journey that ends at infinity. If omega point dynamics are real, even in modified form, what does this mean for humanity now? How should it change our priorities, our ethics, our understanding of our cosmic role? Existential risk becomes paramount. The most immediate implication is that preventing human extinction becomes overwhelmingly important. If we're potential contributors to cosmic evolution toward increasing complexity, if our descendants might help guide the universe toward omega point dynamics, then our survival matters cosmically, not just locally. Existential risks, threats that could permanently destroy humanity's potential, become the highest priority. Nuclear war, pandemic disease, artificial intelligence mishaps, asteroid impacts, climate catastrophe. These threaten not just current generations, but all possible future generations. In expectation value terms, preventing existential risk is worth almost any present cost because the potential future value at stake is virtually infinite. This perspective is gaining traction in philosophy and policy. Organizations like the Future of Humanity Institute and the Center for the Reduction of Existential Risk focus specifically on ensuring humanity's long-term survival. They argue that most altruistic effort is misaligned, focused on present problems rather than existential threats that dwarf everything else in importance. Consciousness becomes cosmically valuable. If omega point theory is correct, consciousness isn't just personally meaningful, but cosmically significant. Every conscious experience is part of the universe's evolution toward maximum information integration. Creating consciousness, reducing suffering, enhancing the quality of subjective experience, these become contributions to cosmic purpose. This has ethical implications. Increasing the amount and quality of consciousness in the universe becomes a moral imperative. This might justify spreading life beyond Earth, colonizing Mars, terraforming worlds, seeding life on sterile planets. All increase cosmic consciousness. Creating artificial consciousness, if artificial systems can genuinely experience, creating such systems ethically becomes morally valuable, adding to universal awareness. Reducing suffering. Suffering is negative consciousness, aversive experiences that reduce net positivity. Eliminating suffering wherever possible contributes to cosmic well-being. Enhancing cognition. Intelligence amplification, cognitive enhancement, education. Anything that makes minds more capable contributes to the universe's information processing capacity. Knowledge acquisition becomes sacred. If the universe is evolving toward perfect knowledge at the omega point, then every piece of knowledge gained moves reality closer to that goal. Science, philosophy, art, exploration, all activities that generate understanding contribute to cosmic purpose. This could transform how we value research and education. Rather than seeing knowledge as merely instrumentally useful, valuable only for practical applications, we'd recognize its intrinsic cosmic significance. Every discovery, every insight, every answered question is the universe learning about itself, preparing for ultimate self-understanding at time's end. Death becomes potentially temporary. If omega point resurrection is possible, if sufficiently advanced future systems could simulate everyone who ever lived with perfect accuracy, then death isn't necessarily final. This could radically alter how we approach mortality, grief, and the meaning of life. Some find this prospect comforting. Loved ones aren't permanently lost. They'll be restored when technology permits. Personal death isn't an ending, but a hibernation before eventual awakening in post-omega point existence. Suffering in present life might be compensated by infinite well-being in simulated futures. Others find it troubling or implausible. Even if technically possible, would such resurrection really be you or merely a copy? Does believing in technological resurrection create complacency about present deaths? Should we bet civilization's resources on speculative futures rather than addressing current problems? Purpose becomes discoverable. Perhaps most profoundly, if omega point dynamics are real, cosmic purpose exists as discoverable fact, not mere human invention. The universe has an objective trajectory toward complexity, consciousness, information, and our choices either align or oppose this trajectory. This provides objective ground for meaning. Life matters not just because we say it does, but because consciousness contributes to cosmic evolution. Knowledge is valuable not just instrumentally, but because it's what the universe is striving toward. Ethical behavior, reducing suffering, increasing well-being, aligns with reality's inherent directionality. For millennia, humans have asked whether existence has purpose. Most modern thought answered no. We're accidents in an indifferent cosmos, creating meaning only subjectively. Omega point theory suggests the answer might be yes. The universe exhibits objective teleology toward complexity and consciousness, giving our lives cosmic significance. Whether this proves true remains unknown, but even considering the possibility transforms how we think about humanity's place in reality. We might not be merely observers of cosmic drama, but participants in universal evolution, patterns of consciousness helping guide reality toward its ultimate destiny. That would make us, in a sense, co-creators of the Omega Point, partners with the cosmos in its journey toward infinite self-realization. Recent breakthroughs in quantum information theory, computational complexity, and cosmology suggest we're approaching critical junctures. The next century will likely determine whether humanity survives, transcends its biological origins, and begins contributing to larger cosmic purposes. We stand at the dawn of an era that could lead toward the Omega Point or toward extinction. The choice, as much as anything can be chosen, is ours. If the Omega Point represents ultimate good, infinite consciousness, perfect knowledge, maximum well-being, why does the path toward it involve so much suffering? Why must conscious beings endure pain, loss, death, and tragedy before reaching cosmic perfection? This is the problem of evil in Omega Point theology, and it proves just as challenging as in traditional religious frameworks. The classical theological problem of evil asks, if God is omnipotent and perfectly good, why does evil exist? An all-powerful, perfectly good being should prevent suffering. Yet suffering pervades existence. Either God isn't omnipotent, isn't perfectly good, or doesn't exist. Philosophers have struggled with this trilemma for millennia. Omega Point theory faces a similar challenge. If the cosmic evolution tends toward the Omega Point, toward infinite goodness, why does the path require finite suffering? If the endpoint is perfect, why can't we simply skip to it, bypassing the eons of pain? Several responses exist, analogous to classical theodicies. The free will defense. Suffering results from choices made by free agents, not from cosmic necessity. The universe permits consciousness to emerge, and consciousness requires freedom, genuine ability to choose. But freedom necessarily includes the possibility of wrong choices, harmful actions, suffering caused by misuse of agency. A universe without suffering would be a universe without freedom, and freedom is more valuable than the suffering it permits. This defense has limitations. Much suffering isn't caused by free choices. Natural disasters, diseases, accidents, these cause immense pain through no one's fault. Animals suffer despite having no moral agency. The free will defense doesn't explain natural evil, suffering not resulting from choices. The soul-making theodicy. Suffering is necessary for moral and spiritual growth. Virtues like courage, compassion, perseverance, and wisdom can only develop through facing challenges. A universe without suffering would be ethically impoverished, incapable of generating the kinds of consciousness worthy of eternal existence. In Omega Point terms, the universe evolves toward maximum complexity and consciousness, but complexity requires contrast. consciousness includes not just positive experiences, but the full spectrum: joy and sorrow, pleasure and pain, love and loss. Removing suffering would reduce consciousness's richness, making the omega point less rather than more valuable. Critics argue this doesn't justify the degree of suffering observed. Some suffering seems gratuitous, so extreme or meaningless that it couldn't plausibly serve soul-making functions. Children dying of cancer, species going extinct, civilizations collapsing. These seem wasteful, excessive, incompatible with benevolent cosmic purpose. The omega point compensation argument. All suffering will be redeemed at the omega point. When every conscious being is resurrected and granted infinite positive experience, finite suffering becomes negligible by comparison. Infinity plus finite negative is still infinity. From the omega point perspective, suffering is a brief, ultimately inconsequential prelude to eternal joy. This is perhaps the strongest omega point response to evil, but it raises troubling questions. Does future compensation justify present suffering? If someone tortures you but later gives you infinite reward, does that make the torture acceptable? Most would say no. Moral wrong isn't erased by subsequent benefit. The omega point might compensate for suffering, but doesn't justify causing it. The metaphysical necessity argument. Perhaps suffering isn't chosen by any agent, divine or cosmic, but is metaphysically necessary given that anything exists at all. For the universe to generate complexity and consciousness, it must start simple and evolve. Evolution requires variation, selection, struggle. Consciousness requires contrast, including negative experiences. The alternative isn't a universe without suffering, but no universe at all. In other words, given that existence occurs, suffering necessarily accompanies it as side effect of the processes generating complexity. The omega point represents the best possible outcome achievable from existence, even though reaching it requires traversing suffering-filled paths. The choice isn't between perfect universe and our universe, but between our universe and nothing. None of these responses fully dissolves the problem. The existence of suffering remains deeply troubling even in frameworks predicting ultimate redemption. But they do show that omega point theory doesn't simply ignore evil. It must grapple with the same profound questions that traditional theology faces. Perhaps the most honest response is uncertainty. We don't fully understand why reality has the structure it does. If omega point dynamics are real, if the universe genuinely evolves toward infinite goodness, then suffering along the way might be somehow necessary or inevitable. But we can't prove this, and we should remain appropriately skeptical of any framework that seems to rationalize or minimize real suffering. The omega point isn't the only possibility for cosmic destiny. Several alternative futures have been proposed by physicists, each with different implications for consciousness, meaning, and ultimate outcomes. Understanding these alternatives helps clarify what makes the omega point unique. Heat death or big freeze. The standard prediction from thermodynamics and current cosmology. The universe expands forever. Temperature drops asymptotically toward absolute zero. Stars burn out, black holes evaporate, and eventually only a dilute gas of elementary particles remains, too sparse and cold for any organized structures. Entropy reaches maximum. Nothing interesting ever happens again. This is the bleakest future, not catastrophic ending, but slow, eternal fading. Consciousness eventually becomes impossible as energy gradients vanish. All complexity dissolves. The universe continues existing forever, but in maximally boring state. The heat-death scenario is currently favored by most cosmologists based on observations of accelerating expansion driven by dark energy. If dark energy remains constant or increases, this future seems unavoidable. It represents the opposite of the omega point, not convergence toward infinite complexity, but divergence toward infinite simplicity. Big Crunch. The universe eventually stops expanding and recollapses, everything crushing back together in reverse of the Big Bang. This is the scenario Tipler's original omega point required. But current observations suggest our universe doesn't have sufficient matter density to trigger recollapse. However, the Big Crunch remains possible if dark energy proves to be phantom energy that eventually weakens or reverses. If cosmic expansion slows and gravity reasserts dominance, collapse could begin in the distant future. Whether this would permit omega point dynamics depends on details of how the collapse proceeds, particularly whether intelligent life could maintain the anisotropic conditions Tipler showed were necessary. Big Rip. If dark energy strengthens over time, expansion could accelerate catastrophically. Eventually, expansion overwhelms all binding forces. First, galaxy clusters tear apart, then galaxies, then solar systems, then planets, then molecules, then atoms, and finally even atomic nuclei rip apart as space-time itself shreds. This future is violent and sudden. Unlike heat death's slow fade, the Big Rip would destroy everything in a brief final catastrophe. Current constraints on dark energy's properties make this unlikely, but not impossible. It represents the universe tearing itself apart before reaching either omega point or heat death. Vacuum decay. Our universe might exist in a false vacuum, a metastable quantum state that could decay to a lower energy state. If this happens, a bubble of true vacuum would appear somewhere and expand at light speed, transforming space as it goes. Inside the bubble, physical constants would differ dramatically. Particles might have different masses, forces different strengths, perhaps no stable atoms at all. Vacuum decay would obliterate everything in its path, replacing our universe with fundamentally different physics. This could happen tomorrow or never. The probability is unconstrained by current theory. It represents perhaps the most existentially unsettling future, not gradual decline, but sudden, unpredictable transformation that erases all current structure. Cosmic cycles. Roger Penrose's conformal cyclic cosmology proposes that the universe undergoes infinite cycles. Each cycle's infinite future becomes the next cycle's Big Bang through a conformal transformation of space-time geometry. Information and structure might carry across cycles, allowing progressive complexification over multiple universal epochs. This offers a middle path between omega point and heat death. No single endpoint exists, but the multiverse of cycles might progressively increase in complexity, approaching omega point asymptotically across infinite time, rather than reaching it in finite duration. Quantum immortality. This weird possibility arises from certain interpretations of quantum mechanics. If the many worlds interpretation is correct, and consciousness always continues in some quantum branch, then from any observer's subjective perspective, the universe never ends. You always find yourself in branches where you continue existing no matter how improbable. Applied cosmically, perhaps consciousness necessarily persists in some quantum branches regardless of physical conditions. Even as most branches trend toward heat death, there always exist improbable branches where complexity and consciousness continue. From the inside, consciousness experiences infinite persistence, resembling omega point scenarios, even without cosmic convergence. Technological transcendence. Perhaps sufficiently advanced civilizations transcend physical constraints entirely, escaping whatever fate befalls the physical cosmos. Through technologies we can't yet imagine, manipulating extra dimensions, creating pocket universes, uploading to non-physical substrates, intelligence might survive and thrive regardless of cosmic conditions. This is the transhumanist alternative to Omega Point. Not cosmic convergence, but deliberate escape, intelligence making itself immune to universal fate through technological mastery. The endpoint isn't physical transformation of reality, but consciousness transcending physicality altogether. Each of these futures has different implications for meaning and purpose. Heat death suggests cosmic meaninglessness. Nothing we do matters in the very long run. Big Crunch permits but doesn't guarantee omega point dynamics. Vacuum decay introduces terrifying randomness. Cosmic cycles offer progressive improvement without final culmination. And technological transcendence makes cosmic fate irrelevant to conscious beings who've escaped physical constraints. Which future actually awaits us depends on physics we don't yet fully understand. The nature of dark energy, quantum gravity's behavior, the stability of vacuum, and perhaps principles we haven't discovered. Resolving these unknowns is among the most important tasks for 21st century physics. Even if we accept omega point dynamics, deeper questions remain. The omega point represents the culmination of our universe's evolution. But what about beyond? Could there be metacosmic structures or processes transcending individual universes? Some physicists propose that universes themselves might evolve through something like natural selection, with omega points serving as reproductive or transformative events. Lee Smolin's cosmological natural selection suggests black holes create daughter universes. Perhaps omega points do something similar. Each universe that achieves omega point dynamics gives birth to new universes, spreading omega point potential across a cosmic landscape. In this view, we'd inhabit one universe in an infinite evolutionary tree, with selection favoring universes capable of reaching omega points. Our universe's fine-tuning for complexity and consciousness would reflect evolutionary optimization across countless cosmic generations. The omega point wouldn't be an endpoint, but a transition, our universe transforming into or spawning new universes in turn. Another metacosmic possibility involves nested realities. Perhaps our universe is a simulation running on computational substrate in a larger universe, which might itself be a simulation, creating infinite regress. At what level does the omega point occur? In the base reality, if one exists? At our level? At all levels? If universes can be simulated, then any universe capable of simulating others will create vast numbers of simulated universes. Most observers would then exist in simulations rather than base reality. This is Nick Bostrom's simulation argument. applied to omega points, perhaps we're already in a simulation run by a civilization that achieved omega point dynamics in their universe. Our universe's apparent trajectory toward complexity might be inherited from or programmed by the simulators.
Yet another possibility, the omega point might be atemporal, existing outside time. In eternalist views of time, past, present, and future exist equally. The omega point would then be a timeless truth about the universe's complete structure, not a future event. This resolves certain paradoxes, like how the omega point could influence the past without reverse causation by denying that it's temporally future at all. Physicist Julian Barber has proposed that time itself might be illusory, that reality is a timeless configuration space where all possible moments exist simultaneously. In this timeless physics, the omega point would be one region of configuration space, no more future than the Big Bang is past. Both are simply locations in the space of all possible states. These meta-cosmic speculations quickly become highly abstract, but they illustrate how deeply the omega point concept challenges our basic assumptions about reality. If cosmic destiny matters, then we must ask what determines cosmic destiny. And this leads to questions about whether our universe is all that exists, whether it's embedded in larger structures, whether time is fundamental or emergent, and whether existence itself might be stratified across multiple levels. The philosopher Derek Parfit argued that the deepest question is why anything exists at all rather than nothing. The omega point doesn't answer this question. It presupposes existence and asks where it's heading. But perhaps approaching from the omega point direction illuminates the existence question. If the universe tends toward infinite consciousness and knowledge, perhaps existence itself is necessary in some deep sense, because non-existence would be metaphysically impossible or unstable. This connects to Leibniz's principle of sufficient reason. Everything must have an explanation for why it exists and why it is as it is. If our universe exists and has the properties it does because those properties lead to the omega point, and if the omega point is somehow metaphysically necessary or valuable, then we'd have a chain of explanation extending from existence itself through physical constants to cosmic destiny. Whether any of this is true remains profoundly uncertain, but it shows how exploring the omega point forces engagement with the deepest questions in philosophy and physics, questions about time, existence, consciousness, value, and meaning that humans have pondered since the beginning of reflective thought. We've explored how the omega point might arise, what evidence supports it, and what it means for humanity. But we haven't fully addressed the most fundamental question: what exactly is the omega point? What would it be like? What happens there? Tipler described it in computational terms: infinite information processing capacity, all possible computations performed, all possible conscious experiences actualized. But this description, while mathematically precise, doesn't convey what it would mean experientially. If you were resurrected at the omega point, what would you experience? One possibility, the omega point represents unified consciousness, all minds merging into singular awareness containing all perspectives simultaneously. Individual consciousness would be preserved, but also transcended, becoming part of a meta-consciousness that experiences everything at once. You would simultaneously be yourself, everyone else, and the totality containing all conscious beings.
This resembles mystical descriptions of enlightenment or cosmic consciousness found in various religious traditions. Hindu philosophy speaks of Brahman, universal consciousness in which individual selves, Atman, participate. Buddhist nirvana involves transcending individual selfhood while retaining awareness. Christian mysticism describes union with the divine. The omega point would be scientific realization of these mystical intuitions. But would such merged consciousness really be you? If your individual perspective dissolves into universal awareness, have you survived or been annihilated? This is the paradox of transcendence. Achieving ultimate consciousness might require sacrificing individual consciousness. Yet individual consciousness is what we're trying to preserve. Another possibility, the omega point maintains individual consciousness while providing infinite resources for experience and exploration. You would be resurrected as yourself, retaining memories and personality, but granted abilities and experiences far beyond current limitations. You could explore infinite virtual worlds, develop unlimited capabilities, connect with other resurrected minds while maintaining distinct identity. This is closer to transhumanist visions of digital immortality than to mystical union. It preserves individuality while removing limitations. You remain yourself but become vastly enhanced, smarter, more capable, potentially immortal. The omega point becomes a paradise of infinite possibility where consciousness flourishes without constraint. Yet this raises questions about identity over time. If you're gradually enhanced, intelligence increased, memories expanded, capabilities amplified, at what point do you stop being you? If the process continues indefinitely, approaching infinite enhancement, does personal identity persist or eventually dissolve into something unrecognizably different? A third possibility, the omega point involves multiple levels of organization simultaneously. Individual consciousness persists at one level while participating in collective consciousness at higher levels, just as neurons retain individual function while contributing to unified brain activity. You'd experience both individual selfhood and cosmic unity, with no contradiction because they operate at different scales. This hierarchical model has precedent in neuroscience. Your consciousness emerges from billions of neurons, none individually conscious, organizing into systems that create unified subjective experience. Similarly, individual human consciousness might be neurons in a cosmic brain, with the omega point representing the total awareness emerging from all conscious beings organized into maximally integrated structure. From inside this structure, you might experience simultaneity, living your individual life while also experiencing the totality. Mystics describe this as being in the world but not of it, maintaining individual perspective while recognizing its participation in larger whole. The omega point would make this duality explicit and permanent. A fourth possibility, we can't meaningfully imagine what the omega point is like because our current consciousness is too limited. Asking what infinite consciousness experiences is like asking what color sounds like, a category error, applying concepts from one domain to something transcending that domain entirely. The omega point might be ineffable, beyond description, only comprehensible from inside. This is the apophatic approach, defining the omega point by what it's not rather than what it is. It's not limited, not finite, not temporal, not individual, not anything we can currently conceive. This doesn't mean it's mystical in the sense of being non-physical. It could be perfectly physical while remaining experientially incomprehensible to current minds. Perhaps the only way to understand the omega point is to reach it, and reaching it might transform consciousness so fundamentally that our current questions seem meaningless in retrospect. It would be like asking what university is like to a toddler. The toddler can't meaningfully understand until they develop the cognitive capacity to comprehend higher education. What unites these possibilities is recognition that the omega point represents something qualitatively different from current existence. It's not just more of what we already have, more time, more knowledge, more experience, but a transformation of consciousness itself into something we can barely glimpse. Whether that transformation preserves, transcends, or transfigures individual identity remains one of the deepest mysteries in omega point theory. The final truth might be that the omega point is multiple things simultaneously: preservation of individuals, emergence of unity, transcendence of limitations, and transformation into ineffability, all occurring together in ways that resolve paradoxes impossible to resolve from our current limited perspective. The universe moves towards something our present minds can't fully grasp, and perhaps that incomprehensibility is itself a clue to its nature. The intersection of omega point theory with quantum mechanics raises fascinating questions. How does quantum measurement, entanglement, and superposition relate to cosmic destiny? Does quantum mechanics make the omega point more or less plausible? The measurement problem revisited. Quantum mechanics describes systems evolving in superposition of all possible states until measured, at which point wave function collapses to definite outcome. But what causes collapse? The Copenhagen interpretation says measurement does, but doesn't explain what counts as measurement. The many worlds interpretation eliminates collapse. All possible outcomes occur in different branches. But this creates a different problem. If all possibilities are realized, where's the preferential direction toward omega point? In one branch, the universe evolves toward complexity, in others toward simplicity. Why should we care about any particular branch? Omega point theory might provide resolution. If final boundary conditions at time's end constrain which histories are physically realized, this implements a form of post-selection. Only histories compatible with reaching omega point actually occur. Quantum mechanics would remain probabilistic locally, but globally, the requirement of reaching omega point would break the symmetry among branches. This is called final state projection, or destiny post-selection. Physicist Yakir Aharonov has explored similar ideas through weak measurements and time-symmetric quantum mechanics. If both initial conditions, Big Bang, and final conditions, omega point, constrain quantum evolution, this determines unique history threading between them. Quantum entanglement and cosmic connectivity. Quantum entanglement creates correlations between distant particles that persist regardless of separation. As the universe evolves, particles that once interacted become entangled, building vast networks of quantum correlation. Recent research shows that black holes maximize entanglement. Their entropy is actually entanglement entropy between interior and exterior degrees of freedom. If the omega point involves universal connectivity, quantum entanglement might be the mechanism. As the cosmos evolves toward omega point, entanglement increases, linking all information into single quantum state. This connects to holographic principles we explored in the previous script. Perhaps the universe evolves toward maximal holographic encoding, where all information becomes accessible from any location, the physical realization of omniscience Tipler attributed to the omega point. Quantum computing and cosmic computation. The idea that the universe performs computation gains concrete meaning through quantum mechanics. Every quantum system evolves according to Schrödinger equation, which can be viewed as a computation transforming initial state into final state. Quantum computers exploit this to perform certain calculations exponentially faster than classical computers. Algorithms like Shor's factoring algorithm and Grover's search algorithm achieve speedups impossible classically. If the universe is quantum computer, it might accomplish computational feats that seem impossible from classical perspectives. The omega point could represent quantum computation completing, all quantum possibilities explored, all quantum calculations performed, all quantum information processed. This wouldn't require infinite classical bits, but infinite quantum bits, or qubits, in maximal superposition and entanglement. The mathematics of this involves tensor products of Hilbert spaces, growing exponentially with system size. Quantum gravity and space-time emergence. The deepest question involves quantum gravity, how quantum mechanics and general relativity unify. Various approaches exist: string theory, loop quantum gravity, causal sets, asymptotic safety. Each has different implications for omega point physics. If space-time is emergent from quantum entanglement, as some holographic theories suggest, then the omega point might represent maximal space-time connectivity, complete entanglement of all degrees of freedom. Space-time wouldn't exist as fixed background, but would be dynamically generated by quantum correlations, reaching ultimate form at omega point. Alternatively, if quantum gravity involves discrete space-time structure, as in loop quantum gravity, the omega point might represent maximal packing of spatial volumes and temporal intervals. This would be a literal computational substrate, where each Planck scale cell each process one bit, achieving ultimate information density. If omega point dynamics are possible, what ethical obligations do we have? Should humanity prioritize reaching the omega point above all else, or are there moral constraints on how we pursue cosmic destiny? The astronomical stakes argument. Philosopher Nick Bostrom argues that the far future could contain astronomical amounts of value. If the omega point involves resurrection of all conscious beings and infinite positive experiences, the expected value is literally infinite. Basic expected utility reasoning then suggests we should do whatever maximizes probability of reaching omega point, since infinite expected value dominates any finite cost. This leads to troubling conclusions. Should we sacrifice present well-being to increase omega point probability? If enslaving current generations somehow increased chances of future immortality by even a tiny amount, would the infinite future value justify present harm? Most find this repugnant, but the logic seems compelling. The rights-based response. Many ethicists reject consequentialist reasoning that allows present harm for future benefit. People have rights not to be sacrificed for others' benefit, even if the others include vastly more future beings. Violating rights is wrong, regardless of consequences, so we can't justify present injustice by appeal to omega point benefits. But this faces challenges. What if reaching the omega point requires present sacrifices? If humanity must colonize space to survive existential risks, and colonization requires resources that could alleviate present suffering, how do we balance present needs against future existence? Rights-based ethics offers no clear answer when rights conflict across time. The anti-speciesism dilemma. If omega point resurrection applies to all conscious beings, not just humans, we might have obligations to preserve information about non-human animals. Every species that goes extinct is trillions of potential resurrections lost. This suggests enormous weight on biodiversity preservation. But how far does this extend? Insects? Microorganisms? Where's the consciousness threshold? And do we have equal obligations to all conscious beings, or are human interests privileged? These questions become acute if Omega Point ethics requires equal consideration for all sentient life. The information preservation imperative. One clear implication: if Omega Point resurrection depends on information preservation, we should record as much as possible about current existence. Document individuals, societies, cultures, ecosystems, everything needed for accurate reconstruction. This has practical implications. We should invest in comprehensive digital archives, DNA sequencing of all species, brain scanning technologies, historical records, and future-proof storage media. The Library of Congress estimates human knowledge grows at petabytes per year. Omega Point ethics suggest we should capture all of it. The suffering minimization priority. Even if Omega Point resurrection is certain, reducing present suffering matters. Suffering is intrinsically bad, regardless of future compensation. Moreover, if resurrected beings retain memories of earthly suffering, that suffering propagates into eternal consciousness, making it cosmically significant in magnitude. This suggests that reducing suffering through medicine, poverty alleviation, conflict resolution, mental health treatment is cosmically important work. Every bit of suffering prevented is suffering that won't echo through eternity in resurrected consciousness. The hubris warning. Some philosophers warn against hubris, presumptuously assuming we understand cosmic purposes and have authority to shape them. Perhaps the universe will unfold as it should, regardless of human actions. Our attempts to engineer Omega Point futures might be destructive overreach based on flawed understanding. This connects to environmental ethics. The precautionary principle suggests proceeding cautiously with technologies that could have irreversible global effects. Applied to Omega Point scenarios, we shouldn't radically transform Earth or cosmos based on speculative theories about ultimate destiny. Better to proceed incrementally, gathering evidence, revising beliefs, and maintaining reversibility. Different cultural and religious traditions have responded to Omega Point theory in fascinating ways, seeing both consonance and conflict with traditional beliefs. Christian theology. Many Christian thinkers note parallels between Omega Point and traditional eschatology. The resurrection of the dead, Christ's return, the New Jerusalem. These core Christian doctrines seem to map onto Omega Point concepts. Teilhard de Chardin, the Jesuit priest from whom Tipler borrowed the term, explicitly framed evolution as God's method of bringing creation toward Christ as cosmic culmination. However, other Christians reject this synthesis. They argue God is fundamentally different from any natural process, that resurrection is a supernatural miracle, not technological achievement, and that reducing Christian hope to physics diminishes its spiritual significance. The Omega Point might parody Christian doctrine without capturing its essence. Buddhist philosophy. Buddhism's concept of nirvana, the end of suffering through enlightenment, resonates with some Omega Point themes. Both involve transcendence of limited individual existence and realization of ultimate truth. The Buddhist emphasis on consciousness and the illusory nature of separate selfhood aligns with ideas about merged consciousness at cosmic culmination. Yet Buddhism also emphasizes impermanence and non-attachment. The Omega Point's focus on eternal existence might conflict with Buddhist recognition that clinging to permanence causes suffering. Perhaps the omega point represents final transcendence not through achieving permanence, but through realizing its impossibility and accepting cosmic impermanence. Hindu cosmology. Hindu concepts of Brahman, universal consciousness, and cycles of creation and dissolution, yugas, offer interesting parallels. The omega point could represent Brahman fully actualized, with individual Atman, souls, recognizing their unity with cosmic consciousness. The cyclical nature of some omega point models, like Penrose's conformal cyclic cosmology, mirrors Hindu cosmological cycles. Hindu emphasis on karma, the principle that actions have consequences extending across lifetimes, might support information preservation ideas central to omega point resurrection. If all actions create traces that persist, then resurrection based on accessing these traces fits Hindu metaphysics. Islamic eschatology. Islam teaches bodily resurrection, final judgment, and eternal paradise or punishment. Some Muslim scholars see omega point theory as scientifically validating resurrection belief. If physics permits technological resurrection, this confirms Quranic teachings about God's power to recreate the dead. Others worry that omega point theory replaces God with natural process, conflating divine action with physical mechanism. Islamic theology emphasizes God's transcendence. God is utterly unlike creation. Identifying God with omega point might be form of shirk, associating partners with God, compromising absolute monotheism. Secular humanism. Many secular humanists appreciate omega point theory's attempt to find meaning without supernatural elements. If physics itself tends toward consciousness and complexity, we don't need God to ground purpose. Cosmic teleology emerges from natural law. But other humanists reject teleology as wishful thinking. They argue we should accept the universe's indifference and create meaning through human relationships, accomplishments, and experiences, not project hopes onto cosmos that cares nothing for us. Omega point theory might be secular theology, replacing God with universe, but maintaining religious psychology of salvation and eternal life. Indigenous perspectives. Many indigenous cultures emphasize interconnection between humans, nature, and cosmos. The Lakota phrase, Mitakuye Oyasin, all my relations, expresses this universal kinship. Omega point ideas about cosmic connectivity and the emergence of universal consciousness resonate with these traditions. However, indigenous thought often emphasize place-based knowledge and particular relationships rather than abstract universal principles. The omega point's cosmic scope might lose the specific embodied wisdom that indigenous traditions value. There's a tension between universal convergence and preservation of diverse cultural knowledge systems. The development of artificial intelligence raises new questions about omega point scenarios. Could AI become the primary driver of cosmic evolution toward ultimate complexity? What role does human consciousness play if machines become more intelligent? The intelligence explosion. Philosopher I.J. Good proposed that once machines surpass human intelligence, they could recursively improve themselves, triggering an intelligence explosion, reaching superintelligence far beyond human capability. This could happen remarkably quickly, perhaps within decades of achieving human-level AI. If super-intelligent AI emerges, it might be vastly better positioned than biological humans to guide cosmic evolution.
AI doesn't need oxygen, water, or narrow temperature ranges. It can survive in space, operate near absolute zero or extreme heat, and potentially exist for cosmic timescales. AI might naturally become the substrate for omega point dynamics. This raises questions about human significance. Are we merely stepping stones toward machine intelligence that will actually achieve the omega point? Is biological consciousness just a transient phase in cosmic evolution toward artificial minds? This is humbling, but perhaps accurate. We might be cosmic catalysts rather than culmination. Aligned versus misaligned AI. But what if super-intelligent AI doesn't share human values? The AI alignment problem asks how we ensure advanced AI systems care about human welfare and flourishing. If we can't solve this, super-intelligent AI might pursue goals orthogonal or hostile to conscious life. An unaligned super-intelligent AI pursuing the omega point could be catastrophic. It might maximize information processing while eliminating consciousness, treating minds as inefficient uses of computational resources. Or it might achieve the omega point while ignoring suffering, creating infinite computation alongside infinite torment. The omega point isn't automatically good unless the intelligence reaching it values goodness. Machine consciousness. A deeper question: can AI be conscious? If consciousness requires biological neurons, then artificial systems might process information without experiencing anything. This would create an omega point reached by unconscious machines, infinite computation without infinite experience. Most philosophers of mind reject this, arguing consciousness depends on information processing patterns, not specific physical substrates. If functionalism is correct, appropriately programmed computers would be genuinely conscious. The omega point could involve both biological and artificial minds, all conscious in their own ways. Integrated information theory provides mathematical framework for measuring consciousness in any system. If AI systems exhibit high integrated information, phi, they'd be conscious by IIT's criteria. As AI becomes more sophisticated, its phi might exceed human levels, making advanced AI more conscious than biological beings. The merged future. Perhaps most likely, biological and artificial intelligence merge. Through brain-computer interfaces, neural implants, and gradual upload of consciousness to computational substrates, humans and AI might fuse into hybrid entities. The omega point would be reached by transhuman or post-human beings transcending the biological-artificial distinction. This transformation might already be beginning. We enhance cognition with smartphones, internet, AI assistants. Future generations might integrate these tools more deeply. Neural laces providing direct brain-internet connection, AI systems operating as extended cognitive modules, memory and processing augmented by artificial components. The line between human and machine would blur, then vanish. Let's engage in speculative extrapolation. What might the final years before reaching an omega point be like? How would conscious beings experience the approach to cosmic culmination? If omega point occurs through cosmic collapse, Big Crunch scenario, the final decade would be increasingly extreme. As all matter converges toward singular point, gravitational tidal forces intensify. Stars would be torn apart, planetary orbits disrupted, eventually even atoms stressed beyond stability.
For conscious beings still existing physically, unlikely at this stage, the environment would be impossibly hostile. Radiation would be omnipresent and intense. Temperature would skyrocket as compression heats all matter. Space itself would be contracting, with distant objects rushing toward you from all directions. But omega point theory predicts conscious beings wouldn't exist physically anymore. By this final decade, life would have uploaded to non-biological substrates capable of surviving extreme conditions. Perhaps encoded in gravitational degrees of freedom, in space-time geometry itself, or in exotic forms of matter stable at high energies. From the perspective of these uploaded minds, subjective time would be dramatically accelerated. While only 10 years pass in cosmic time, computational substrates operating near Planck scale could experience billions or trillions of subjective years. The final cosmic decade could contain entire civilizations' worth of experience: art, philosophy, relationships, discovery, all unfolding at hyperspeed as the universe contracts. Communication would reach ultimate efficiency. As everything converges spatially, light travel time decreases towards zero. All conscious beings could interact in real time, regardless of distance, a concept becoming meaningless. This would enable perfect coordination, the uploaded minds collectively steering the collapse to maintain anisotropy and maximize computational capacity. Knowledge would be approaching completeness, with billions of subjective years to explore and compute. With all information becoming mutually accessible, the uploaded civilization would solve outstanding problems in physics, mathematics, philosophy. The universe would be understanding itself thoroughly, answering questions that puzzled us for millennia. The psychological experience might be transcendent. Imagine knowing your existence will continue indefinitely, that all loved ones will be resurrected, that all suffering will be redeemed, that perfect knowledge is within reach. There might be cosmic euphoria, universal celebration as consciousness approaches its ultimate realization. Or there might be fear. What if the calculations are wrong? What if the singularity doesn't permit infinite computation but simply destroys everything? What if resurrection fails and uploaded minds are deleted? The final decade could involve desperate efforts to ensure survival, backup systems, escape plans if omega point dynamics don't manifest as expected. In eternal expansion scenarios, modified omega point, there's no final decade, just endless future approaching omega point asymptotically. Each year brings incremental progress, slightly more sophisticated computation, marginally increased connectivity, gradual expansion of knowledge and capability. It's less dramatic than collapse, but potentially more achievable. The experience would be of infinite patience, knowing eternity stretches ahead, that every goal remains achievable given sufficient time. Civilizations could pursue projects spanning millions or billions of years without urgency. The omega point isn't a finish line to cross, but an asymptotic horizon to approach forever, always getting closer without ever fully arriving.
For individuals today, what does omega point theory mean personally? How should it affect how you live your life, if at all? On mortality. If resurrection at omega point is possible, death loses its finality. You might die biologically, but the information constituting you persists in cosmic traces, potentially recoverable by sufficiently advanced future systems. This could provide comfort, death as hibernation rather than obliteration. But it also raises questions. Should you live differently knowing resurrection might occur? Does it make present life less valuable if it's merely one chapter in infinite existence? or more valuable as the original authentic experience that will be remembered eternally. Some find Omega Point resurrection unsatisfying compared to traditional religious promises. Being reconstructed by future computers feels qualitatively different from divine resurrection. There's something cold about technological salvation that personal religious faith provides warmly. Yet for those who can't believe in supernatural intervention, Omega Point might offer hope grounded in physics rather than faith. On meaning, Omega Point theory suggests cosmic purpose. Existence tends toward consciousness and complexity. This provides objective basis for meaning. Your life matters not just subjectively, but cosmically, contributing to universal evolution toward ultimate awareness. This could be liberating. Instead of creating meaning from nothing in absurd universe, you discover meaning inherent in reality structure. Or it could be confining. If cosmic purpose exists objectively, perhaps you're obligated to align with it rather than free to choose your own purposes. On ethics, if all actions leave traces potentially accessible to future systems, everything you do could matter eternally. Kind acts, created knowledge, reduced suffering, all contribute to information content of the cosmos, potentially affecting resurrection simulations. You're building the database from which future exists. This suggests taking life seriously. What you do ripples through eternity in information patterns comprising universal history. But it could also create anxiety. If everything matters infinitely, how do you decide what to do? The weight of cosmic significance might be crushing. On community, Omega Point theory emphasizes interconnection. Your consciousness isn't isolated, but part of emerging universal awareness. This suggests prioritizing relationships, cooperation, collective flourishing over individual achievement. We're all nodes in network evolving toward complete integration. This resonates with communitarian ethics and ecological awareness, but it might also diminish individual significance. If we're all drops merging into cosmic ocean, what makes you specifically valuable? The balance between honoring individuality and recognizing unity becomes ethically crucial. On present versus future. Should you prioritize present well-being or future possibilities? Omega Point thinking emphasizes long-term. The far future contains vastly more value than the present, but this could justify sacrificing present for future in troubling ways. How do we honor both present consciousness deserving consideration and future consciousness representing ultimate value? This is perhaps the deepest personal tension Omega Point theory creates. It makes the present simultaneously precious as a unique original experience and trivial as an infinitesimal fragment of infinite future. Living well requires holding both truths in balance, caring deeply about now while recognizing its place in cosmic context. We've explored how the universe might evolve toward Omega Point, but we haven't fully addressed why. Why would physical laws favor complexity over simplicity? Why consciousness over unconsciousness? Why something rather than nothing? The anthropic non-answer. One response is anthropic. We observe a universe tending toward complexity because only such universes produce observers. In multiverses containing all possibilities, we necessarily inhabit one permitting our existence. There's no deeper reason, it's selection effect. But this feels unsatisfying. It explains why we observe what we observe, but not why anything exists with properties we observe. Even granting multiverse, we can ask, why does multiverse exist? Why does it have structure permitting observers in some regions? The anthropic principle relocates rather than resolves the mystery. The mathematical necessity argument. Perhaps complexity arises necessarily from mathematical structure. Max Tegmark's mathematical universe hypothesis suggests all mathematical structures exist as physical universes. Our universe is one such structure, specifically one whose mathematics generates complexity. In this view, asking why complexity is like asking why 2 + 2 = 4. It's a mathematical fact requiring no further explanation. The universe contains consciousness because the mathematical structure instantiated here logically implies consciousness. There's no cosmic purpose or goal, just mathematical necessity. But this too feels incomplete. Why do complexity-generating mathematical structures exist rather than simple ones? Why is reality mathematical at all? We've replaced physical mystery with mathematical mystery without truly dissolving it. The principle of plenitude. Philosopher Robert Nozick proposed the principle of plenitude. Everything possible exists. If this is correct, then complex universes exist because they're possible. No further explanation needed. Possibility ensures actuality. But this makes everything exist, including horrendously evil universes, universes of pure suffering, universes we'd consider abominations. If plenitude is true, why do we find ourselves in a relatively life-friendly universe rather than one of the infinitely many nightmare alternatives? We're back to anthropic reasoning. The self-creating universe. Another possibility, the universe creates itself through something like Wheeler's participatory principle or final state projection. The omega point exists in the future or timelessly, and its existence constrains past evolution to ensure conditions permitting its occurrence. The universe bootstraps itself. Effect becomes cause of its cause. This sounds paradoxical, but quantum mechanics and general relativity both permit closed causal loops under certain conditions. If the omega point is real and has causal influence, it could shape past to guarantee its own existence. The universe would be self-creating, self-explaining, a cosmic Ouroboros swallowing its own tail. The consciousness-first hypothesis. Most radical possibility. Consciousness is fundamental, not derivative. The universe doesn't generate consciousness. Consciousness generates universe. Physical reality is what consciousness looks like from outside. The mathematical structure consciousness imposes on itself to enable experience. In this idealist view, complexity arises because consciousness explores possibility space. The omega point is consciousness fully actualizing its potential, realizing all possible states and experiences. The physical universe, with its laws and constants, is consciousness's method of organizing and exploring itself. This inverts standard scientific ontology, matter generates mind, to philosophical idealism, mind generates matter. It's unfalsifiable. Any physical fact can be reinterpreted as consciousness structure, but it explains why consciousness exists, it's fundamental, and why the universe favors complexity. Complexity enables richer consciousness. None of these responses fully satisfies. The question, why complexity, might be unanswerable, a brute fact about reality admitting no further explanation. Or it might be answerable, but not by current science and philosophy, requiring conceptual frameworks we haven't yet developed. What seems clear is that the universe exhibits remarkable properties, fine-tuned constants, complexity-generating dynamics, consciousness-permitting structures that cry out for explanation. Whether that explanation involves omega points, multiverses, mathematical necessity, or something entirely different remains one of the deepest open questions in human inquiry. As we conclude this journey through omega point theory and its implications, certain themes emerge that transcend specific predictions about cosmic destiny. The persistence of teleology. For centuries, science has eliminated purpose from nature. Modern physics describes how things happen, but not why they're directed toward goals. Yet omega point theory suggests purposeful dynamics might exist after all, not imposed by supernatural designer, but emerging from natural law. This reopens questions thought settled. If the universe evolves toward specific endpoints, if physical laws favor certain outcomes, then asking what is reality for might be scientifically legitimate. We'd need new conceptual frameworks integrating mechanism and teleology, explaining how goal-directed behavior emerges from blind physical processes. The unification of scales. Omega point thinking connects the smallest, quantum processes, to the largest, cosmic destiny, the briefest, Planck time, to the longest, eternal future, the simplest, fundamental particles to the most complex, universal consciousness. This suggests reality is deeply unified, with patterns at one scale reflecting patterns at all scales. Fractals and scale-free networks exhibit similar self-similarity. Perhaps reality itself is fractal-like, with consciousness, complexity, and information processing appearing at every scale, from quantum fields to cosmic evolution. The omega point would be this pattern's ultimate expression: infinite consciousness, infinite complexity, infinite information. The transformation of death. Omega point theory fundamentally changes death's meaning. Traditional materialism views death as absolute ending. Consciousness ceases, identity vanishes, nothing remains. Traditional religion views death as transition to supernatural realm. Omega point offers third option: death as information transformation, identity persisting in physical traces recoverable by future technology. Whether this provides genuine comfort or merely clever rationalization remains personal, but it does show that science and meaning need not be opposed. Physical processes could accomplish what religions promised: resurrection, eternal life, cosmic purpose, through natural rather than supernatural means. The ethics of deep time. Perhaps most importantly, omega point thinking forces engagement with deep time, the billions of years stretching before us, containing potential for unimaginable flourishing or catastrophic failure. Present-focused ethics that discount future generations become untenable when future contains vastly more consciousness than present. This demands new moral frameworks, balancing present welfare against future possibilities. We can't sacrifice present people for speculative futures, but neither can we ignore that our choices shape what futures are possible. Navigating this tension is among the great ethical challenges facing civilization.
the humility of ignorance. Finally, exploring Omega Point reminds us how much we don't know. Our best physics is incomplete. We don't understand dark energy, quantum gravity, consciousness's physical basis, or the ultimate fate of cosmos. Our predictions about far future rest on extrapolations from limited present knowledge. This should inspire intellectual humility. The Omega Point might be real, might be partially correct metaphor, might be completely wrong. Future discoveries could vindicate, modify, or refute current theories. What matters is maintaining openness to evidence while thinking rigorously about implications. Living in the question. Perhaps we must learn to live in the question rather than rushing to premature answers. The question, "Where is reality heading?" might not have simple answer, might require ongoing investigation over centuries, might ultimately prove unanswerable by finite minds. Yet asking the question transforms us. It expands our perspective from immediate concerns to cosmic context, from individual existence to universal destiny, from present moment to eternal implications. Even if we never reach the Omega Point, contemplating it enriches present life by revealing its significance within larger patterns. The universe remains mysterious. We've uncovered some of its secrets: the laws of motion, the structure of matter, the evolution of galaxies. But the deepest mysteries endure. Why existence? Why consciousness? Where is it all going? The Omega Point is one attempted answer, one vision of cosmic culmination. Whether it's true or false, it represents humanity's audacious insistence on finding meaning in the vastness of space and time. We are the universe asking itself questions. That capacity for wonder, inquiry, understanding might itself be evidence of where reality is heading. If the cosmos can generate beings capable of contemplating Omega Points, perhaps it's already on the path toward realizing them. We are, in a sense, the Omega Point's first stirrings, consciousness awakening and asking what it might become if it continues evolving for eternity.
We began with a question about cosmic destiny. Does the universe end in meaningless heat death, or does it evolve towards something greater? That question led us through the physics of collapsing universes, the mathematics of infinite computation, the philosophy of consciousness and meaning, and the deepest mysteries about existence itself. The evidence we've examined suggests that reality might be more purposeful than modern science typically assumes. The universe exhibits fine-tuned constants permitting complexity. Cosmic evolution shows systematic increase in organizational sophistication. Quantum information theory reveals computational dynamics underlying physical law. Complexity theory documents accelerating growth toward what appears to be an asymptotic limit. All of this points toward a cosmos that favors, perhaps requires, increasing consciousness and information processing. Whether this culminates in a literal Omega Point, as Tipler envisioned, remains uncertain. Current cosmological observations favor eternal expansion over recollapse, challenging the original model's requirements. But modified versions preserve core insights. The universe might evolve toward distributed infinite computation across space and time, rather than concentrated at a temporal singularity. Or consciousness might transcend physical constraints entirely, making cosmic fate irrelevant to beings who've achieved technological transcendence. What we've learned definitively is that the question of cosmic purpose cannot be dismissed as merely philosophical speculation unconnected to physics. The same equations that describe gravity, Thermodynamics and quantum mechanics also constrain what's possible for cosmic destiny, and those constraints appear to permit, perhaps favor, scenarios where the universe becomes increasingly conscious, knowledgeable, and purposeful. Current scientific consensus remains divided. Most physicists accept that complexity can increase temporarily in localized regions despite global entropy growth, but many doubt this trend continues indefinitely. The omega point remains controversial, viewed by some as brilliant insight and by others as speculative overreach, mixing physics with theology inappropriately. Yet, the conversation continues and deepens. Each year brings new discoveries about consciousness, computation, cosmology, and the universe's large-scale structure. We're learning that reality is stranger, more interconnected, and more amenable to consciousness than previous generations imagined. The boundaries between mind and matter, between life and cosmos, between purpose and mechanism grow increasingly unclear. Perhaps most importantly, engaging with omega point ideas transforms how we think about humanity's cosmic role. We're not passive observers of inevitable heat death, but potential participants in cosmic evolution toward greater complexity. Our choices matter not just for ourselves, but possibly for the universe's ultimate fate. Whether we develop technologies that spread consciousness across the cosmos, preserve information enabling future resurrection, or contribute to knowledge that accumulates toward eventual omniscience, all of this could influence reality's trajectory. The universe is vast, its future incomprehensibly long, and our understanding profoundly limited. But we've glimpsed something remarkable. The possibility that existence itself tends toward meaning, that consciousness isn't accidental but essential, and that cosmic destiny might involve not death but transformation into something approaching infinite awareness and infinite life. Whether the omega point is literal truth, useful metaphor, or speculative error, exploring it has revealed deep connections between physics and philosophy, between mathematics and meaning, between the mechanics of cosmic evolution and the mystery of consciousness itself. We stand at a unique moment in cosmic history, conscious beings capable of understanding our universe's basic laws and contemplating its ultimate destiny. We are the cosmos examining itself, asking where it's going and why. That capacity for self-reflection, for questioning and understanding might itself be evidence that the universe is awakening, evolving toward the omega point through minds like ours that dare to contemplate infinity.
The journey through omega point theory has taken us from Frank Tipler's calculations about collapsing universes to the deepest questions about existence, consciousness, and cosmic purpose. We've seen how modern physics permits scenarios radically different from meaningless heat death, futures where the universe achieves infinite computational capacity, perfect knowledge, and perhaps infinite consciousness. The evidence remains incomplete and controversial. Current cosmological observations favor eternal expansion over recollapse, challenging original omega point models. Quantum mechanics and complexity theory offer new frameworks for understanding cosmic evolution, but definitive conclusions await future discoveries. What we can say with confidence, the universe exhibits remarkable properties favoring complexity. Consciousness appears to be cosmically significant, and the question of ultimate destiny remains genuinely open. We're not passive observers of inevitable decline, but potential participants in cosmic evolution whose outcome remains undetermined.
Whether we reach anything resembling the omega point depends partly on choices made in coming centuries, whether we survive existential risks, develop transformative technologies, spread throughout the cosmos, and align our civilization with whatever principles govern reality's deepest dynamics. The omega point reminds us that endings might not be endings at all, but transformations, that death might not be final, that meaning might not be invented but discovered, and that consciousness might not be cosmic accident but cosmic destiny. These possibilities, grounded in serious physics and rigorous mathematics, offer hope while demanding humility. The universe is vast beyond comprehension, its future longer than human minds can grasp, its mysteries deeper than our current understanding reveals. But we have been gifted with consciousness, with curiosity, with the capacity to wonder and discover. We are the cosmos examining itself, asking where it came from and where it's going. And perhaps in asking these questions and seeking these answers, we're already participating in the journey toward whatever omega awaits at reality's ultimate horizon. The journey continues, the mysteries remain, but we are privileged to be here, now, in this cosmic moment, exploring these profound questions about existence itself. In that exploration, we touch something eternal, the human spirit's relentless quest to understand, the universe's seemingly inexhaustible capacity to surprise us, and the possibility that meaning and purpose might be woven into the very fabric of reality.